Did you see that? A section of the sun's surface seems to have broken away, creating a massive vortex-like swirl above the star. What's happening here? Truth be told, our knowledge of the sun is still surprisingly limited, despite its immense importance for life on Earth. That said, scientists do have a working theory for this strange occurrence. They suspect that a portion of the sun's superheated plasma erupted and detached, forming a crown-shaped spiral structure over the solar North Pole. This swirling motion, possibly the result of a solar prominence, remains under investigation. Even seasoned astronomers are puzzled, since this phenomenon is unlike anything they've documented before. Still, the footage is extraordinary, and it's not just this one event. The sun as a whole is entering a more turbulent phase. We're seeing a rise in solar flares and sunspots. In fact, it has emitted solar flares daily in early 2023, including powerful X-class and M-class eruptions, the most intense types known. Sound alarming? Not entirely. The sun experiences cyclical changes in activity roughly every 11 years. These solar cycles involve shifts in the magnetic field and can range from relatively calm to extremely active periods. When the sun's magnetic poles weaken and reverse, known as a solar maximum, we see the peak of these wild solar behaviors. We're currently approaching that maximum. Researchers estimate the magnetic flip could happen by July 2025. But since the sun is still such a mystery, no one can say for sure. What's clear though is that the current cycle, starting in December 2019, has already exceeded expectations in both intensity and unpredictability. Which brings us back to the mysterious vortex spotted on February 2nd, 2023. It started as a solar prominence, a glowing arc of plasma looping out from the sun's surface. Prominences like this are fairly common, especially near the sun's corona, its outermost layer. In this case, the prominence took on a hedgerow-like appearance, typical for such formations. However, what shocked scientists was that the prominence seemed to detach completely and began rotating around the pole of the sun at around 60 degrees latitude, moving at a blistering pace of about 60 miles per second for 8 hours straight. One solar scientist who's monitored solar activity for decades admitted he'd never seen anything quite like it. Unfortunately, observing the sun's polar regions is incredibly difficult, so answers may be slow in coming. Back in 2021, NASA's Parker Solar Probe achieved a milestone by actually entering the sun's upper atmosphere for the first time. It collected solar particles and studied magnetic fields, marking a leap forward in solar exploration. By flying closer to the sun than any spacecraft before, it uncovered data never seen from Earth. One key finding: strange zigzag patterns in the solar wind called switchbacks. Initially, their origin was unclear, but we now know they form right at the sun's surface. Keep in mind, the sun lacks a solid surface like Earth. Its atmosphere is a superheated plasma bound by gravity and magnetic forces. As energy builds and pushes material outward, it eventually escapes the sun's grip. This escape point is known as the Alphen critical surface, the boundary where the solar wind truly begins. Once past that point, solar material races into space so fast that it loses connection to the sun, dragging magnetic field lines with it. The Parker probe passed through this zone multiple times, revealing that the boundary isn't smooth. It's wrinkled and uneven, with ridges and dips. At one point, the probe flew through a pseudo-streamer, an enormous magnetic structure visible during solar eclipses. Inside it, conditions were strangely calm, a dramatic contrast to the violent solar wind outside. Let's talk about solar flares, bursts of energy that can have serious effects on Earth. These outbursts emit radiation capable of disrupting radio signals and damaging electronic systems, including satellites and power grids. While most flares are short-lived, larger ones, especially those classified as X-class, can cause prolonged solar storms. A particularly powerful solar storm would arrive in stages. First, ultraviolet and X-ray radiation would strike Earth's atmosphere, disturbing radio communication. Then, a radiation storm would follow. Lastly, a massive wave of solar particles would hit, interacting with Earth's magnetic field and potentially causing chaos across the globe. The worst-case scenario, GPS systems could fail, satellites might be fried, and even astronauts on spacewalks would have minutes to find shelter before exposure. If those solar particles hit power infrastructure, it could damage transformers and lead to blackouts. A storm of this scale might cost the global economy up to $2 trillion. Thankfully, we have constant solar monitoring from ground-based observatories and satellites. If a major storm were on its way, we'd likely have a few hours to a couple of days to prepare. With fast action, such as temporarily shutting down vulnerable infrastructure, the worst effects could be minimized. So while the sun's recent behavior is certainly fascinating and sometimes alarming, it's also pushing the boundaries of what we know. With each new discovery, like the bizarre solar vortex or the Parker probe's findings, we get a little closer to understanding the fiery heart of our solar system.